Yeah, I tried to make my dots big and easy to read there. All right. Oh, excuse me. Oh. So, all right. A couple minutes after 10. Got about half of you here. Our last class. I know it breaks everyone's heart. I'm ready for a break too. For some reason it seems like a long term. Oh well. And letting folks in. Yeah. And another.
Good morning.
Good morning. Well, let's see. No more homework. I wasn't really going to worry about discussion grades this week. I do appreciate all your feedback. That's nice, and especially between each other. Good for you folks, helping each other out there. Um, let's see, test tomorrow, of course. The usual, take the test and then send me your scratch work. It's set up again for 75 minutes, hour 15. Just, give you a little extra. It's about 10
How
questions.
many questions yeah. on the test?
Yeah, 10, I think it's 10 or 11, like I said yesterday. It's the same kind of time frame. We can't really ask you much any more than that. So you can sort of plan accordingly. Let's see. I will then get your scratch work evaluated and do any points adjusting probably Friday morning. And Mom will be open all through Friday. So definitely I'll get it done in the morning. Mom will be open so you can go back and check your overall, did you pass the final and overall grade. I turn grades in on Monday before noon. I have to turn grades in officially, but I think you don't see them officially until Wednesday. But as far as this class is concerned, you should be able to figure out pass or no pass based on, just Friday afternoon check in. And you still actually have my email address. You can still always email me, even if the mom course is not active, not available to you anymore. Sort of thinking here, business, just wrapping things up. Really, for the most part, most of you, vast majority, doing just fine. All you got to do is pass that final, right? Like I mentioned in my post, that's a departmental rule. You got to pass the final to pass the class. And so, but I get to grade it just like I always get to grade all the tests and look at your scratch work for partial credit if appropriate. Just wanted to mention those of you who might be going on to Math 96, and if are interested, there's two or three in this class that are participating in what's called the Math Marvels program. Extra sort of like support, tutoring, you might say, available. The program is designed to serve, I believe it's a low income, first time in the family college students to be successful in their math courses. So if that sounds, and I think there's possibly some financial assistance, I'm not sure about that. If any of you are interested in that, I encourage you to look for Math Marvels on RCC's website, probably the mathematics homepage, or even if you're not sure where to go, send me an email and I'd be glad to connect you, send a referral or that kind of thing. But, might be an option for you to just get a little extra help and support if you were going on. In the unlikely, unfortunate case, if you happen to be someone who's going to have to take Math 60 again, that option is, that's program is available for Math 60 students also. Yeah, let's not count on that. Let's hope you all get over that hump. Okay. So also, I don't know if you are looking in at Blackboard for other classes right now or not, but I'm sure in the last couple of weeks, there was a prompt in Blackboard for you to write any comments about the course or the instructor, that weird guy. Please feel free to write your comments, feedback, whatever, there if you'd like to do that. Otherwise, I probably really won't see you again after today. So best of luck to you all, okay? And I'll have to apologize. I didn't record yesterday, yesterday's review. If you were really wanting to see what I might have had to say, you could go the same place where I have this term's YouTube videos in YouTube. You could, enter Martinich Math 60, and you kind of have to just scroll down to the dates at the end of when fall term would have been, like very late November or early December. The last listed classes in December of last year would have been the reviews, the same thing I did last year, if you're really looking for an online review. But otherwise, you can go review each chapter individually, okay? There, I think that's all my talking. All right, so here we are, kind of looking chapter 4 stuff here, right? And so we need to be able to calculate or determine, count the squares, determine the slope if we have a graph to work with. Here I made up one where the units are our usual 1 unit per square. And on graph paper, you want to look for those couple of points where the line actually intersects the grid very clearly. And then you can count your, the change in X, rise over run, right? Y's over X. Make sure it's Y's on top and X is on the bottom, right? So you count your squares. Here, what I was trying to show, right? Like from here, I went over 1, 2 in the X direction. And from here, I went up 1, 2, 3, 4, 5 in the Y direction. So that was the slope I was hoping you would get from that graph. Count the squares. Okay. And sometimes now, because of what else I was trying to ask you to do here, I use the y-intercept, right? But you might just have to look for, 2 other points, 2 places where that line crosses out in the middle of anywhere. Make sure you're finding good intersection points and count those squares. How about the y-intercept value? Well, right there, y-intercept value. Again, if it asks for ordered pair, make sure you write the ordered pair, not just -1. It'll mark it wrong, and I'll go back and give you some partial credit because you had the right idea, but show the zero and the other value. Okay? Now, if you have that information, hopefully you recall, you ought to be able to write an mx plus b, right, shaped equation, where m is the slope and b is the y-intercept value. So there it is, right? That would be the equation of that line. Any comments or questions there? All right. Let me do something else then. All right, I'm going to see if I can, excuse me, make this graph grid work for maybe another problem. I'm having to rewrite the whole thing. Let's say, for instance, this time, these lines are changing by hundreds, okay? Hundreds, and these are going by fives. And I'm just practicing this idea. Be careful to pay attention to the units on the axes. So let's say I've got a graph, and I'm going to make one up here. All right. How about same question? First of all, to start, right, slope. That's really the point I'm trying to, the main point here. If the units are not just ones, right, you've had questions like that in application problems in particular, and unfortunately I've seen too many errors in finding the slope in that situation. Y-intercept also, right? I guess I gave you that one, and probably can still come up with the equation of the line then, if you can get those two values. And yeah, I think my lines look pretty clear on the screen. Hopefully you can count that. Now, so the change in my x direction, right? Can you count that, right? If I went from, let's say I started here and I went over to here, how many units? Well, it's 1, 2, 3 lines, but if they're all fives, right? That's 5, 10, 15. It's not just 3, it's 15 because of the 5 there. All right, and if I went from here down, right? I went down. Negative slope, obvious there, right? I'm going to say, we know that's going to be negative. I'm going to have to do some, reduce that fraction, I think. But from here, I went 1, 2, 3, 4, but those are hundreds, 400, right? 1, 2, 3, 4, that's up at 500. 5, 4, 3, 2, 1, right? So I went down 400. So there, 400, negative 400 over 15. Now we can divide those all by some fives. Let's see, that's what, 80? 80 over 3, negative 80 over 3. So that's slope. That's what I see there. So emphasizing unit size, and for this example, negative, right? Y-intercept, just mentioned it a second ago, 1, 2, 3, 4, 500. There as an ordered pair. And equation again, I've got a slope and I've got a y-intercept. So often it's just out in front, right? So hope that's okay. All right, questions? Moving along now, all right? And I'm going to go back to ones, my axes again, and I'll get rid of that one. See if I get at least one more graph out of this grid. Get that dot. Ones and ones again here. How about now? Can you graph that line going the other way around? You graph it this time. All right. What techniques do we have for graphing? Well, you can always do one of these things, a T-chart. But if you're familiar enough with that form, right? We know slope from that form. We know the intercept value from that form. And those are what I would consider like shortcuts, better, easier ways to graph that line than having to actually calculate solutions, right? Calculated points, solutions. So if I was looking at this, hopefully I'm seeing my slope value is, well, it's a whole number. I always think of those as a fraction, so I get the rise over run, right? And my y-intercept value, right? The b value. So this would be, I would think, let's say, easier way to graph this one. If you can start from that point, right? 1, 2, 3, 4, 5, just barely got my graph. Now, from that known point, always got to have a known point when you're going to then find a second one using the slope. Start from the one you know and count squares and find the second point. Over 1, up 3. Over 1 and up 3 gets me a second point right there. Nobody's even asking me what the coordinates are, but you know, I can figure out if I wanted to, and there's an ugly looking line. All right, that's what you want to be able to do if asked to graph and you have an equation. Now, we could pick some nice x values, 0, 1, 2, -1, whatever. They work very, very nicely, and just come up with points out there in the plane, and then if you've done it correctly, connect the dots, and that should be your line. Let's just do that again, okay? And so let's do one that has a fraction and a negative slope. All right, how about -2/3 x plus 3? Same thing. Can you graph that one? For some reason, graphing is still something any of us are not comfortable with yet. Got a little congested yesterday, so. Same idea, I would think. If you thought you needed to build a T-chart here to calculate some points because of the fraction slope, here's where we usually recommend the x values that you would choose should be multiples of the denominator 3. So just something like -3, 0 still works. 0 is 0 times 3, it works, right? So I can put those values in there for the x and find the corresponding y values. If that's the way, if you're uncomfortable with the other technique, that should work if you're careful about plugging them in. Otherwise, we know -2/3 is our slope, and here's that idea, positive divided by negative. You got to call one of the values negative and the other value positive. Doesn't really matter. And the y-intercept again, 0, 3. Just checking, nobody's trying to log in here. There's that one right there. Nope, that's wrong. There's that one. X is 0. Right? X is 0. Y is 3. Oops, 1, 2, 3. Yeah, really unfortunate. Don't mix up your X's and your Y's. Right? This is the X-axis. This is the Y-axis. Now, from that starting point, let's use our slope. That means I'm going to go over 3, but down 2. Right? Over 3 from my starting point. 1, 2, 3, and down 2. 1, 2. And that line should look something like that. Better on your own graph paper. Okay, slope and intercept. I think it's the easiest way to graph it. This works. All right, one more. Why? Because we have to look at that other form. Again, no more dot. How about one of them in that shape? Can you graph that one? Now, couple options. Some of you really like rearranging it and putting it in that mx plus b shape. Fine, right? I'll just walk through that in a second. Otherwise, here's one of those where I always recommend that you see if the intercept method will work out nicely. If I put in a 0 for x, does this number divide into that one? Yeah, it does. And similarly, if I put in a 0 for y, the 4 divides into 12. So I would get nice whole numbers for my intercepts. So that's kind of what this example is about. It's trying it that way. Okay. I will do the rearranging in a second also. How about if I put it in 0 for the x? Let's right, kind of just do the cover up. If 0 for x, negative 3y is 12. Divide by negative 3, and what do I get? Negative 4 for the y value. So there's 1 point. 0x, negative 4, that's my y-intercept. 1, 2, 3, 4. If I put in a 0 for the y, I get 4x is 12, divide by the 4, and I get a 3. Okay. There's my x-intercept, 3, 0 on the x-axis. So, and that line would look like that, huh? Now, let's see, if I wanted to put it in an mx plus b shape, usually I leave the y's and then move the x's, right? If I subtract the x's, I'm going to go down here, right? Subtract the x's, I still have negative 3y minus the x's, and the positive 12 is there. I divide then by negative 3, every term by negative 3. Now that's negative, negative is positive 4/3, but that's minus 4. There's that y-intercept we found the other way. And this is saying over 3 up 4. Actually, I think it's this, that other point just by chance. So if it's in that form, consider this method as maybe easiest, but otherwise you can carefully rearrange it and put it in that shape. All right. La-di-da. Well, I'm just going to make up something from this problem. What if this y-axis represented, it's going to be weird because I'm going to draw a different line. Okay. Here's some other line. Ignore this one. All right. That y-axis represents cost, some money. And let's say this x-axis represents, let's say, a weight, a quantity in ounces, like I'm at the grocery store, right? What are the units of that slope? Right? What are the units? Interpret the slope in this problem. You know, 6 ounces costs, $1.50 or something like that. What are the units of the slope? And here I've been trying to drill in you the idea, the slope units interpreting are just the y units over the x units, or dollars per ounce, or cost per ounce, units of the slope. Just compare the y units to the x units. Miles per gallon, or something, whatever the problem says, or miles per hour, that was time, right? Or rate of speed, something like that. Okay, and looking through my list of things to do here. We got to write some equations, right? Got to write some equations. We actually wrote some equations based on the graph. I think I'm done with the graph right now. But let's just do one of these. Let's say 3, 5, and -2, 7. Find the slope between those 2 points. Slope formula, gotta know that one. How do you calculate a slope if you know just 2 points out of the blue like that?
y2 minus y sub 1 over x2 minus x sub 1. Is that one?
Yeah, good.
Yay.
And somebody's telling us the formula. Yeah, there's the formula. Now you gotta, it doesn't matter which one's 1 or 2. It doesn't, I promise. As long as you're consistent. So, you might say 7 minus 5, right? For the y's, make sure you get your y's on top. Here's what I keep drilling. If you start with this y value, you have to start with that x value, same point, starting point. -2 minus a 3, or if I'd done 3 minus a negative, if I started the other direction, I'd have had a minus minus, right? So here, 7 minus 5 is a 2, -2 and minus 3 more is -5. You might put that all out in front. -2 fifths is what I'm trying to come up with there for that slope. And then, oops, here it is. Right. Let's see. That was on my graph grid. What's the slope of that line? Yes. Nothing. Silence. The slope of that line is horizontal. Is slope is 0, right? Depending on where that was on the graph. Right, the equation of that line, 1, 2, 3, 4. I said it, I made it up to sloppy 5, right? The y value is always 5, horizontal line. What's the same? It's the y that's always the same, not the x. X changes all over the place, right? So, what's the other example like that? All right, this one. Vertical line, too steep to measure. Slope is undefined, right? If you tried to calculate it from 2 points, you'd get something with a 0 in the denominator. Can't divide by 0. Undefined. And similarly, number 1, 2, 3, 4. What's the x value that's going through it? The x is always the same no matter what y value. X is 4 is what I just made up. My vertical line. So you might be asked that kind of question, what is the slope of that kind of line? Or if you're given an equation, can you graph that line? Oh, y is always -2. No matter what x is, y is always -2. Right? Or given the graph, come up with its equation. One of those two kinds of shapes there. Yeah. All right. We did this from the graph already, but if you have that kind of information, can you write the equation of that line? That's supposed to be 0 right there. 0, -2. What's special about that point that I bothered to give you there? Because x is 0, that's your y-intercept. So that's the information that just easily plugs into mx plus b, right? Slope, I know the slope, I know the y-intercept. Six minutes of problem, but I did that one in 30 seconds, on to the next. More time for the next one. All right? What if I tell you slope and some other point? No, that's where we have to do a little more work. There's those two techniques. You can use the point slope formula. I believe it's actually presented as, you can use, that formula is presented in the test. If you want to use that other formula, right, the y minus y1 equals, you can use that formula, or otherwise you practice solve for b, right, solve for the b value. Oops, looks like somebody fell out and wants to come back in. Trying to come up with the equation if I know a slope and some point that isn't the y-intercept. Now, two techniques there. You get to choose which one you've practiced the most or that you find easiest for you. If you want to use the point, right, there's the point, x1, y1 are the point coordinates. The point slope formula, you just plug what you know into it. So here I go, y minus, what's the y value? Is a 2. Equals m slope 3/5 x minus, what's the x value? 10. There technically is the equation of that line. All the pieces are there, but you'll always be asked to put it in mx plus b shape. So you got to rearrange this one. Right? What does it distribute first? 3/5 times dx minus 3/5 times 10, right? 30 over 5. 6, -6. Finally got to move this number, whatever it is. And there's how you could do it using that point slope formula. Solving for b, we start with our mx plus b form and plug that in for the x value and the y value and the slope, leaving b as the unknown. Notice I made nice numbers. Worked out either. Basically, the fraction multiplies nicely by that, and I think you can count on that. It shows up that way. So what do I get here? I'll divide by 5s. So 2 equals 6 plus b, subtract the 6. And -4 is my y-intercept. B value is -4. Now I can plug in that b and the slope I had, and yes, we still get the same equation. Right. Take the time. There we go. All right. So the more complicated version of that would be if you were given 2 points and asked to come up with the equation of that line. Whenever we're trying to graph a line, just to start with, eventually we need a point and a slope. Here we have 2 points, no problem, but we don't know the slope. So here you have to calculate the slope yourself.
I have a quick question.
Yep. Go
So
for it.
can we use y2 minus y sub 1 over x to find the slope? Can we use that formula?
Oh, the slope formula?
Yeah.
Yes, that's what you need to do. You need to
Okay.
use the slope formula. Yes.
I remember you saying that we couldn't use what formula? Or we shouldn't use that formula. What formula?
I'm not sure what context that.
Okay.
What
I might have heard something different. I'm sorry.
Yeah. So here you want to calculate your slope, right? And again, y2 minus y1 doesn't matter which one's which. How about 7 minus -3? I'm going to do it that way on purpose just to emphasize the negative minus there, right? Started here, so now I'm going to do 5 minus 1. So that's 7 plus 3 is 10 over 4. Please reduce. All right, 5/2 for my slope. Now I've got a slope. Ooh, I didn't make up nice numbers. That is, they're not going to play nicely with my slope. But now I have to choose a point and say maybe solve for b. Right? I'm going to use this one. Solve for b. So -3 equals, right? We're doing mx plus b. Right? -3 equals slope 5/2 times 1 plus b. All right, x value 1. So I'll just have to play with the fractions here a bit. Subtract that, whatever that slope calculation gave you there. Sorry. Thinking too many things. Subtracting the 5/2. That's going to leave the b alone over there. So negative and some more negative. How many halves in 3? Right? 3 over 1 is 6/2. So -6/2 minus 5 more, -11/2. -11 over 2. Good thing you don't have to graph that one, right? That would be my y-intercept. You use that technique, you find your b value, you have the slope value, but you still have to finally go back, write it in that final form. Y equals 5/2 x minus 11/2 is what I worked out here. Let's see. All right. Just gonna double check. Yeah. So that was the, have to do it all. Do the slope and then solve. Find the b. Let's see. Let's see, does this make any sense? Write the equation. That describes How much gas is in his tank? Is in his tank based on how far he's driven. After I fill up completely. Right? I fill it up, and now how much tank gas is left in my gas tank based on how far I've driven. Does that make sense? Kind of just made that one up. But we did a similar one somewhere back in one of our sections. What I was trying to give you is that special information, those two numbers that allow you to put together a certain form of equation. Now, how much is in the gas in the tank based on how far I've driven? The more I drive, I'm going to have less and less and less gas in my tank. What is that telling us about the slope? Right? The farther I drive, the less I have in my tank. This is one of those. Start here. My slope is negative. That's what I'm getting at. Right? M is a negative number. How much gas based on the number of miles? I should have said something like that. Based on the number of miles I've driven. What's the slope number I've given you here in this problem? Here's that big clue there. It's a rate. When you say per, I'm getting 14 miles per gallon. And that's pretty realistic for my old Dodge truck. Someday, maybe I'll get to step up. But I'm getting 14 miles, but my slope is negative 14, right? Per 1 gallon, miles per gallon, right? Oops. Did I do that backwards? Uh-oh, Steve, time out. That's what I get for making it up. Let me think about this, right? Here was, I described a full tank of gas, 18. I'm losing, but these are the number of miles, right? This is gallons on top and miles. Ooh. Well, I messed that up. I'm wondering, does this make sense? Do you see where my confusion is, right? My slope really is saying, I'm using 1/14 of a gallon per mile, right? If I have gallons per mile is what my units on my graph are saying. Don't worry, I won't mess you up like that on a test. Gallons per mile, there are the units. That's why it was important for me to just, at this moment, interpret the units of my slope. If that was the picture, and I started with a full tank of gas, there's my y-intercept. And this is telling me how many miles I'm driving and how much gas I have left, right? So gallons, how many gallons per mile? The change in gallons per the change in miles. Gallons per mile are my units. So 1 gallon, I'm using a 14th of a gallon. 1 mile, I'm using a 14th of a gallon. Stop here, Steve. I'll finish this up. What I was getting at is, there was my equation, right? I started at 18, and for every mile I go, I use a 14th of a gallon. And so I'm going down, get a negative slope like that. Okay. That was probably too confusing. Sorry. Trying to make up something other than all those. We've seen so many of these applications. Used them all up in the systems of equation chapter also. All right, we got just a couple minutes left here. How about any requests? Well, I'll be around today. I have to run a couple errands, then I'll come back. Send me questions if you're working through review, or even if you want to send me a message and say, can you make up one like this or something? And, you know, we could do a little online communicating back and forth. I'll make up a problem and you could practice it. But otherwise, I would really encourage you to just look back at the chapter reviews, sort of, and work off that outline that I posted in the forum a couple days ago. Kinds of things you should expect on the test. All right, I'm gonna.
I have a really quick question about after.
Whoops, I didn't quite catch that. Say again.
I have a really quick question after.
Okay.
It'll be super fast, I promise.
All right. All right, let's see now.
Thank you so much.
All right, you're all very welcome. You know, I know it's frustrating or up and down. It's a challenging class, but you know, I wouldn't be here if I didn't enjoy doing it. And hopefully you're successful. Good luck for everything else you're trying to do. Okay, so take care, folks, and I'll maybe see you around sometime. I wouldn't know you if I saw you out in the community. That's unfortunate. But except maybe Kayleen. See your face all the time.
Yes.
Right, feel free to say hi if you cross paths. I would look like this with my mask. All right, folks, well, good luck. Send me questions if you have anything today, and get that final done tomorrow, and enjoy spring break. All right, see you later then.
Thank
Bye.
you.
Bye. All right, everyone's logging out. Good luck, Dana. See you later. Maybe she stepped away. All right.
Okay, question. On 2.4.
Okay.
So if so I was working through a problem and 12n equals -3.
Yes.
And then there was, sorry, no, scratch that. 12n oh gosh. 12n minus 3 equals 12n minus 3. That's the answer I got.
Oh, okay.
So, and it says classify the equation. So they both equal 0.
So no matter what number I could put in for n, it's always true. No matter what number, I could pick any number, right?
Does it have no solution, or does it have a solution?
It has any number you want to pick, infinite number. Any number will always make these two true, equal each other, right? This is what we call the identity equation.
Oh, it's the identity?
Yeah.
I thought it was the conditional equation, because
Conditional, okay. Conditional is when there is one condition, you know, one solution. Most of them, 99% of what we work with works out to be x equals some number, one number that works, right? That's the conditional. Identity, that means these are identical, right? These are identical.
Okay.
When you do one, like if I made this one a 5, now I get rid of the n's, and I would have -3 equals 5. That's the one that's not true. That's the contradiction.
That's not what this says.
Contradiction, no solution. Here I might say 0 equals 2 or something like that. Contradiction, not true. There's no number that would have ever made this one work. Right? There's no way I can say, if I have 12 of something and I subtract the 3, that's never going to be 12 of some same thing, and add 5. Those will never be the same. -3 equals 5. So contradiction is the no solution.
Thank you. That makes very much sense.
Okay. Now, remember we had sort of similar situation for the systems. Two parallel lines could be have no solution. That was inconsistent. So still, a different term. And, I think if mom asks you that kind of question, it's usually kind of multiple choice, right? Like inconsistent, both of these are sort of negative terms, negative connotations, right? Inconsistent doesn't have a solution for the system. Contradiction means that one equation didn't have a solution. There was no solution. Okay?
Yes. Thank you.
All right, you're welcome.
I will see you later.
Okay, yes, it's been nice to work with you. Okay?
Thank you.
And
Thank you.
good luck tomorrow. All right.
Thank you.
See ya.
All right. Bye.
Bye.